My name is Erik Erhardt, and I was a teaching fellow last year. Surprise, surprise. And I'm going to talk to you about an intervention I did with 6 sections of the 25 sections of Stat 145, our Introduction to Statistics class. I've been wanting to change this course since I was a graduate student myself in 2004 here. And I got a chance to in a climate of strong support from the dean and you guys and the faculty, but with some opposition from the current course coordinator. And but I'll tell you what had happened. Good things. All right. So my 3 goals for this project were to improve the success rate in 145, do some teacher training for our teaching assistants, and convert more students to majors. We have a huge opportunity in statistics because we teach about up to between 1,000 and 1,200 students a semester in this class. It's one of the largest classes in arts and sciences. And statistics is wonderful. And it applies to everything we do. So why shouldn't we be able to capture some of these students going through, right? I capture them from undergraduates to graduate students when they hit my classes, but not in the intro class. Let's see, let's talk about the pass rate. So the pass rate in intro stats is not actually awful. There are some math classes that have been awful, and those have been fixed. But stats have been around 70% pass. Okay, so we're not one of the dean's killer courses, but I think that there's a lot. We can do a little bit better, and we can have better learning outcomes. The second one for teaching assistants. So you can become a teaching assistant in statistics your first semester because you got accepted into the program, which means that you have the background, meaning you've got some calculus and stuff, and we think that you'll be able to succeed as a graduate student. And you can probably speak English pretty well. And so that qualifies you to teach, but you don't need any statistics background to teach Stat 145. And the intro stat class, you really need some deep understanding about what's going on to be able to explain complicated concepts in a simple way. So we're doing a disservice to everyone so far. And so there have been, for over 25 years, George Cobb has been saying there's guidelines for how to teach intro stats. Okay, so there's nothing new. I'm going to follow some of those guidelines and show you what happens. Okay, so each week I designed, actually, yeah, maybe this will talk about this. So we had a weekly schedule. So a typical weekly schedule is show up to lecture, listen to lecture, copy stuff down, go home and struggle. Okay, and then come in for 4 exams and hope for the best. In the flipped classroom, we have a little bit more structure than that. So we have, before each class, the students have to do a little bit of reading and need to watch some videos and take a couple inline video quiz questions to make sure that they're comprehending what's happening. Then you come into class and we've got worksheets each day that they complete so that they're working on that in class, sometimes together in class, typically following maybe a 10 or 15 minute introduction to whatever topic we're covering that day. In the classroom, there's also a peer learning facilitator. So this is an undergraduate student who has taken 2 or 3 classes in statistics and has some experience and cares about teaching and wants to contribute in that way. And then at the end of the week, they've got a quiz that they take at home and something called a learning curve, which is some conceptual questions. Okay? I should say the lecture class also has that learning curve, conceptual questions, and quiz also. But there isn't a chance in class really to engage with the material in the same way. And to get the immediate help that you need by the peer learning facilitator, myself, and peers, Instead, they just go home and they struggle and get frustrated, the way I've seen my students get before I started changing how I teach. All right. So we were able to handle some teacher training in weekly meetings with the PLFs and the teaching assistants whom I was supervising. So we had the design looked like this. I took over 6 of the 25 sections. I had to go to the chair and get I had to wrestle to get those away. But I got it, and 4 of those I performed the intervention in. So we did the sort of a flipped or hybrid version of that. And 2 of them I kept as a control group. Okay? These were TAs who, all of my TAs had taught this class before. 3 of them were really on board to do something different. 2 of them were willing to participate and just taught the way they taught before. And then there were about 20 other sections under the other coordinator. I was able to go to most of the sections of Stat 145 and ask for student consent. Almost a little bit more than half of the students consented to participate, to give data afterwards, and that I can use their data in publications. Okay? The data you're about to see comes from all the students, or almost all the students, okay? Because I could get registrar data for internal study. I have IRB approval for all this stuff. All right, I'm just going to go ahead and skip that, and I'll cover that in a second. So what we're seeing in this array of histograms is we've got 3 rows. The top row are, the labels are on the far right, are the traditional lecture classes, the ones that I'm not involved with. The second row is the lecture classes. That's my control group, 2 sections of students. And the flipped is the bottom, the intervention. This is really just to show over the 4 exams, the first 4 columns. And then the last 3 columns are 3 ways of weighing a final score in the class, because we have different things we got points for. And so I'm trying to find different ways of having them be comparable. I'm just showing that the grade distribution is very similar between all of them. They're all sort of left skewed, right? You typically have lots of B's and A's, whatever, and then it trails off into oblivion. If we summarize by the mean of the students in these 3 delivery methods, the blue line is the flipped class. Those are my sections. And we see about a 4-point difference, okay, on average. This is this is a half a letter grade. This gets you from a B- to an A+, okay? Or in this case, a C+ to a B-, all right, on average. This is the same whether you look at the mean or the median, okay? Here is letter grade distributions. Basically, this is from the registrar. On the left, we have a breakdown by all the pluses and minuses. But I think it's a little bit easier just to look at the right side, where we just look at the whole letter grades, okay? The effect that you see is that almost everyone achieves more, okay? We get lots more A's. We basically have about the same number of B's and the same number of C's, but we have slightly fewer there at the D's and F's, okay? One thing that maybe I'll point out on the next slide is, so here's the significant difference here, that flipped produces more A's. Okay? If you look in terms of all the pluses and minuses, we see significant or more C's than you'd expect on the traditional sections. And I'm not sure what's happening here, whether it's some generosity for students who are maybe not going to have this class count as a prerequisite because their grade's too low, and so that lower bound sort of digs in and pulls them up. But we have, at least in the flipped and, I don't know, in the lecture class too, maybe fewer of the C's than you'd expect.
Eric, can you go back to the prior slide? It looks like the A's are increasing at the expense of the B's from the bar chart on the right, a little bit. Of the B's and the C's, it looks like B's and C's go up to A's.
Exactly.
Okay. And there's fewer F's, but about the same amount of D's.
Yeah.
So in fact, it's like your middle range students improve, and your worst case students.
There's some people you can't help.
I have noticed that.
Yeah, that's a good observation.
So but then I would have predicted that, so
Mm.
interesting.
Yeah.
Okay, sorry.
Yeah, thanks for the observation. Yeah, I think for the students who are engaged and want it, they get it.
They get it better.
That's right. And I should say that what I did was not revolutionary. So I just followed some very simple, long recommended, evidence-based approaches to teaching. Okay? And so that we're doing a little bit better is not surprising. I think in statistics, my main message here is that we have an antiquated, if that's the right word, statistics curriculum. And for 25 years, we've been recommended something different. And so for the rest of my time, which may be 2 or 3 minutes, I'll just say that we should be following the guidelines for assessment and instruction in statistics. There's been 2 versions of this, one in 2005 and a recent one that came out last year. We should be teaching them statistical literacy, conceptual understanding, using real data in the classroom, fostering active learning, using technology, and then improving our own instruction by using assessments and learning from what the students are doing. And if you look at the current curriculum, the current version of statistics meets none of these guidelines. The dean's on board with this, the chair's on board with this, all the faculty are on board with this. I'll be writing a memo in the next couple weeks to the dean to ask for support. We have no money, right? So big fingers crossed here. But the point is that we can do a lot better for our student body, and we know how to do it. And it's not even to do the intervention that I did. It's to do something better than that. Right? I did something, because I'm just one person in one semester. But if we had a professor of practice, someone whose job it is to understand and study statistical education in a university environment and to continually make improvements, and to go to the teaching conferences and to bring back the best ideas and to apply them, right? Just obvious stuff, right? We can make big, big changes. We've been teaching the same way since the 70s and 80s. In fact, in the late 70s or early 80s here, there were computers in the classroom. So, okay. So, my 3 pillars of change are to basically take our 22 to 2,400 students a year and break this into multiple sections of Stat 145. We have so many students, right? There's University of Chicago, I think, has 3 sections of statistics, and they have 2 versions. In my report, there's another school that has 5 sections of statistics and has 3 versions. They have one with a calculus prerequisite. They have, is that an indication to me? Oh, okay. They have a calculus prerequisite, 1 more minute. Calculus prerequisite statistics. They have one for like engineers or something, or like computer-based, and then they have a stat literacy. So we have 25 sections, each with 40 to 60 students in them, most of them about 55 students. And we have 1 version of statistics, right? We're not meeting people's needs because people's needs are different. And we need to train our teaching assistants. And we should not be teaching the way we are. The current version of statistics should go away, and we should have at least these 2 versions, maybe another. And I have a vision for that. So one size does not fit all, and I think that's where I want to end with all that. So thanks, everyone.